Hello everyone, my name is Jakpal. Welcome back to my video. In this video, we will be discussing how to control fragmentation level of transaction log in SQL Server. Fragmentation level of a transaction log is a very important parameter to be monitored because high fragmentation in a transaction log can slow down the performance of your database. So before we understand how to control fragmentation level, let's try to know what is a fragmentation level in a transaction log. Now, fragmentation level of a transaction log depends on the number of virtual log files present inside the transaction log file. Now, what is a virtual log file? We also call it VLF. You can see in this diagram, there are 4 VLFs inside a transaction log file. Now, because transaction log file is group of VLFs, and any transaction which is to be written in the transaction log file, first it gets written in the VLF1. After VLF1 is full, it goes to VLF2, then VLF3, VLF4. After VLF4 is full, it again starts back again from VLF1. That way transactions get written inside the transaction log file. Now here the transaction log file has 4 VLFs. Let's take if the transaction log file of the same size now has 8 VLFs, then the transaction log file has higher fragmentation. So that is how the fragmentation of two transaction log files can be compared, and the transaction log file fragmentation over a period of time can also be monitored. Coming down to next slide, we can also control the number of virtual log files or number of VLFs in a particular in a particular transaction log file. As per Microsoft, the number of VLFs are dependent on the log growth rate inside the transaction log file. If the transaction log growth rate is less than 64 MB, then it creates 4 number of virtual log files. In a similar way, if the transaction log growth rate is between 64 MB and 1024 MB, then the number of VLFs are going to be 8. In this way, you can control the number of VLFs based on the log growth rate. To understand it in more detail, let's take if you have a log size in MB as 60 MB. So this means if it is 60 MB, then it falls under this category, the first row, and the log growth rate is less than 64 MB. So for this 60 MB of log size, 4 VLF will be created. Now if I have to find out what is the size of 1 VLF, so it is going to be 60 MB divided by 4, 15 MB. Similarly, VLF size is going to be 100 MB, okay, for a log size of 800, and VLF size is going to be 156 MB for log size of 2500 MB. That way, the log growth rate is going to decide the number of VLFs and also going to decide the size of each VLF inside the transaction log file. Now, next question is how can I control the number of, how can I control the log growth rate? Because if I control the log growth rate, I can easily control the number of VLFs, and because the fragmentation level of a transaction log depends on number of VLFs, so eventually I am able to control the fragmentation level. So let's understand this with the next slide. Now this slide shows the database properties for AdventureWorks database, AdventureWorks 2012 database. It shows the size for data file and log file for AdventureWorks 2012 database. You can see for a log file, the initial size here is 1 MB, and it has an auto growth. When 1 MB of transaction log file is full, it adds 10% of the initial size. Let's understand how exactly is this going to add the fragmentation level. So because initial size is 1 MB, so this means 1 MB falls in the category, first category, because it's less than 64 MB. So this means it has 4 number of VLFs. So for 1 MB, which is like 1024 KB, with 4 VLFs, the size of 1 VLF is going to be 1024 divided by 4, that comes out to be 200 plus KB. So this means the 1 VLF is going to have 200 plus KB, and there are going to be 4 VLFs for the initial size of transaction log of 1 MB. Now let's consider a case when this 1 MB of initial size is full. So it is going to add another 10% of 1 MB, and 10% of 1 MB is going to be close to 100 KB. Now when it is going to add additional 100 KB of transaction log file, now 100 KB is again less than 64 MB. So in that case, 100 KB divided by 4, that comes out to be approximately 25 KB. So 100 KB additional transaction log file is going to have 4 VLFs, and size of each VLF is going to be 25 KB. So that way you can see for such a short size or small size of transaction log file, you're going to have 4 VLFs. So this means the additional transaction log file is going to have much higher fragmentation level. So let's take if this size of transaction log file is also full, and it starts adding another bunch of transaction log file as part of the auto growth strategy and the setting which is set here. So in that case also, the number of VLFs are going to be higher, and the fragmentation is going to be higher. So you can see that the number of VLFs continue to increase. They are going to be smaller in size. So for this transaction log file, the fragmentation is very high. And when the fragmentation is high, this is going to exert high pressure on CPU, and it is also going to make the writing of transactions inside the transaction log difficult because of high I/O. So this is a problem which typically we face in while we monitoring transaction log on day-to-day basis. But then how to solve this particular problem? To solve this problem, I think the simplest way is first increase the initial size of transaction log, because initial size is 1 MB, due to which the size of your one VLF is coming out to be very less, which is like 200 plus KB. But let's take, instead of keeping it initial size of 1 MB, I keep it 60 MB. Okay, here I showed you that log size of 60 MB is also going to create 4 number of virtual log files. But in this case, the size of one virtual log file is going to be 15 MB. Okay, as per this calculation. So this means your VLF is going to be of much larger size for 60 MB. And because I want to maintain this uniform across every auto growth, even if the new transaction log file gets added to the initial transaction log file. So what I do, instead of having an auto growth of 10%, what I can do, I can simply add a fixed amount of transaction log file here in auto growth. So I will keep it again 60 MB, so that when the initial 60 MB is full and it has to add additional 60 MB, then for that 60 MB it is going to have the same size of virtual log file. Because 60 MB is less than 64 MB, it is going to have like 15 MB of virtual log file. So that way, now after auto growth, it is going to have 60 plus 60, 120 MB, but then it is going to have now 8 virtual log file, and size of each virtual log file is going to be same. So that way, I think this fragmentation problem can be mitigated. But I strongly recommend that if you are making any such changes, please try them first in UAT or development environment before you finally try that in production to solve your transaction log problem. That's how this works, and I wanted to share this with all of you because I think this is an easy fix if you understand this the right way and with the right steps followed by you. And I hope you find this video helpful, and please share it with others if this helps them to solve their problem in their environment. And thank you so much for watching. Have a good day. Bye-bye.